State functions of circuit breakers and list out various capacities of breakers. So the breaker has to work in the following situations when it is connected in the power system. First, current has to be broken to isolate the faulty section when fault occurs. Second, it has to be made on when there is a fault in the circuit, because during the fault the breaker is presently or continuously in on condition. 3. Sometimes the circuit breaker has to be kept in the on state even in the condition of the fault. In such circumstances, the circuit breaker should be capable to withstand the fault current for that much period for which it made on. The following are the ratings of the circuit breakers on the basis of the above requirements, or say capacities. First is breaking capacity, making capacity, short time capacity. So the breaking capacity, also termed as rated breaking capacity, making capacity can be known as the rated making capacity, like this. So these are several functions and capacities of the breaker.
Define breaking capacity of a circuit breaker and state types of it. So the breaking capacity of a circuit breaker is the maximum current that the breaker can interrupt safely without being damaged or causing a hazard. It is an essential specification for selecting a circuit breaker to ensure it can handle fault conditions in an electrical systems. So types of breaking capacities, these are some ratings available on the circuit breaker nameplates, like rated symmetrical breaking capacity, rated asymmetrical breaking capacity, ultimate breaking capacity, service breaking capacity. So these are some types of rating of breaking capacities of a selected circuit breaker.
Explain breaking capacity of circuit breaker. Large fault current flows when the fault occurs in the circuit. This fault current should be broken through the contacts of the circuit breaker. The capability of the circuit breaker to break the fault current is known as the breaking capacity. So it can be defined as for the given recovery voltage and specified power factor and given triple RV, that is rate of rise of restriking voltage, the capacity of breaking RMS value of current is known as the breaking capacity. The breaking capacity can be divided or classified in two ways. One, the symmetrical breaking capacity, and second is the asymmetrical breaking capacity. Now suppose when the fault occurs, there is not only the alternating current component, but there is DC component also present in the current waveform. That means there is asymmetry in fault current. So now suppose let X is equals to the maximum value of the AC component and Y is equals to value of the DC component. Then symmetrical breaking current, that is RMS value of the AC component, is equals to X divided by root 2, and asymmetrical breaking current is equals to RMS value of the total current, that is equals to X upon root 2 raised to 2 plus Y square whole under root. So this can be found out using this formula. Now breaking capacity is normally expressed in MVA, that is million volt ampere or megavolt ampere. If the rated breaking current is I ampere and rated voltage is V volts, then for the three-phase circuit breaker, rated breaking capacity is equals to under root 3 into V, that is the voltage and current, into 10 raised to minus 6 MVA. Actually, it is not logical to express the breaking capacity in MVA, as it is obtained by the multiplication of the short circuit current and the rated voltage. But you think like this, when the short circuit occurs, the voltage across the contact is much lower than that of the circuit service voltage, because when the short circuit occurs, actually that path is shorted, so no resistance is available, so there is no voltage actually. So short means the shorting of the source. This shows that there is no voltage or actually very low value of the voltage present. So the calculated rated breaking capacity like this is not the actual breaking capacity of the breaker. But As far as the concern of the theory, if asked in the examination, you can explain like this. Explain making capacity of circuit breaker. So, many a times it happens that the circuit breaker has to be closed in the short circuit condition. Electromagnetic forces are working at this time and this breaker contact has to be closed in this situation against this type of forces. So this force is proportional to the square of the instantaneous value of the current at the time of the closing. So for making capacity, peak value of the current is taken instead of the RMS current. For this, peak current of the first cycle after closing the contacts is taken because the maximum value of the fault current comes when there is maximum asymmetry in the phase of the circuit breaker during the first cycle. So it can be defined as the peak value of the current including the DC offset component during the first cycle after the contacts of the breaker are closed is known as the making capacity of a circuit breaker. Thus, making current is the maximum value of the asymmetrical current. Now, if the asymmetrical breaking capacity has to be found from the symmetrical breaking current capacity, then the symmetrical breaking capacity should be multiplied by 1.8 factor and the breaking capacity is in the RMS value, so it should be multiplied by root 2. So, the making capacity can be calculated or found out like root 2 multiplied by 1.8 into symmetrical breaking capacity. So, root 2 into 1.8 is equals to 2.55 into symmetrical breaking capacity. So, from the value of the breaking capacity, one can find out the making capacity using this formula. And you can explain the making capacity of the circuit breaker with the concept of having the peak value, not the RMS value at that time.
Explain short time rating of circuit breaker. So, sometimes the fault is of temporary nature and is cleared automatically within 1 or 2 seconds. For example, some conducting object falls on the overhead line conductors and falls down quickly or immediately. Circuit breaker isn't tripped in this short time. The circuit breaker trips when this period is completed or over. So the contacts of the circuit breaker should be capable of withstanding fault current for this certain amount of time or period of time. Short time rating of the circuit breaker depends upon two factors. One is capability to withstand the electromagnetic forces produced by this type of short circuit or fault, and capability to withstand the temperature rise during this time period. The specified short time rating of a circuit breaker of 3 seconds when the ratio of the symmetrical breaking current and rated current is up to 40, but when the ratio exceeds 40, then the short time rating of this breaker contacts is 1 second. So this is how a short time rating of a circuit breaker is explained. State nameplate details of circuit breaker. We are talking about vacuum circuit breaker in this case. So there are several details available on the nameplate of the circuit breaker. First is manufacturer's name and its details, serial number, year of manufacturing of the breaker, breaker type, rated making current, rated frequency, rated voltage, rated current, rated short time current, power frequency withstand voltage, opening speed and closing speed, impulse insulation level, rated breaking current, contact gap, rated operating duty, CT ratio and PT ratio required, weight of the panel, vacuum interrupter type and vacuum interrupter rating. So these are several ratings available on the nameplate of the circuit. The rating of a circuit breaker or a three-phase circuit breaker is 1000 ampere, 500 MVA, 66 kilovolt, 3 seconds is given. Now find the rated service voltage, rated current, breaking capacity, rated symmetrical breaking current, rated making current and short time rating.
So this is a numerical for the subject SGP and on the breaker requirement or the capabilities of the breaker context. So first of all, they have asked rated service voltage. So service voltage is directly given in the numerical itself. This is 66 kV. So rated service voltage is the rated voltage available. This 66 kV is line to line voltage. So rated service voltage is 66 kV line to line. Rated current. So here 1000 ampere is given. This is the rated current of the circuit breaker. So these two are already mentioned. Rated braking capacity. So 500 MVA is the braking capacity already given in the details itself. So these three parameters are found out from the details available readily in the numerical. Now what we have to calculate is rated symmetrical braking current. So for the braking current we require the MVA rating and voltage rating. So MVA multiply by 10 raised to 6 because it is in million volt amperes rating. So it is, or say megavolt ampere rating. So we have to multiply it by 10 raised to 6. So MVA into 10 raised to 6 divided by, see it is root 3 VL IL we require for this. So IL can be calculated by dividing root 3 into voltage. So root 3 and kV, that is 66 kV. So it is in kilovolts. So 10 raised to 3 is multiplied. So by putting this value 500 into 10 raised to 6 divided by root 3 into 66 into 10 raised to 3, we get 4373.86 ampere, rounding off 4374 amperes in RMS. So this is the value of rated symmetrical braking current, that is 4374 ampere in RMS. The another value that we have to calculate is rated making current. So rated making current can be find out using multiply by 2.55 the factor, that is root 2 into 1.8 is 2.55 into rated symmetrical braking current, that is 4374. So we get 11,153.7 ampere. Now here we have multiply by root 2, that is the peak factor. So this value of the current is in peak value. So here it is 11,154 ampere peak value. The last rating they have asked to find out is short time rating. So short time rating is 3 seconds, that is already given in the detail. So 4 parameters are already mentioned in the numerical itself. We have to calculate only 2 parameters, that is rated symmetrical braking current and rated making current. So this is one of the simplest type of numerical of chapter number 5. Write a short note on auto reclosure. So on the basis of the duration of the fault, it can be classified like transient fault, semi-permanent fault and permanent fault. So transient fault is of very short duration and nearly 80% of the faults occurring in the power system are of the transient type. About 12% of the faults are semi-permanent type and nearly 7 to 8% faults are of permanent faults. Thus, most of the faults occurring in the transmission line are of the transient type. Such faults occur due to lightning and due to falling of the branches of the trees on the overhead line. Arcing results due to this. The arc extinguishes when the power supply is switched off for very short duration. The line can then be recharged again afterwards as the fault is cleared during this time period. This principle is used in auto reclosure. An auto reclosure is a protective switching device used in overhead distribution system to automatically open and close a circuit whenever a fault occurs. Now in this, the circuit breaker trips due to the operation of the relay when fault occurs and the circuit breaker is closed after some time. The fault gets cleared if it is of the transient type and line comes in the working condition again. When the fault does not get clear in the first reclosure, second or third attempt is made, meaning auto reclosures can perform multiple reclosing attempts, fast or delayed time. And if the fault is permanent, they lock out and isolate the faulty section from the healthy section. Means if the fault still persists, the breaker is kept open and fault is cleared manually. Oil circuit reclosure is widely used in the unattended type substations in rural distribution system network. Auto reclosure is of single phase type or of three phase type. Most of the faults occurring on the overhead transmission line are of single line to ground faults, so single phase auto reclosures are used widely. Reliability of the system is maintained due to the single phase type auto reclosure, as the power supply is continued or maintained by the two other healthy phases, means the improved system reliability, reduces the percentage or amount of outages, and minimizes the need of manual switching. The modern reclosures are of microprocessor based. They support remote controlling and SCADA system, that is supervisory control and data acquisition, and can provide detailed event records and coordination with the relays as well as with the fuses. The time duration in rapid auto reclosing is 20 cycles, and for delayed auto reclosing duration is for 5 to 30 seconds. So these are some informative notes on auto reclosure. Classify different types of testing of circuit breaker and its basic idea. So tests on circuit breakers are divided into following two types. One is type test and two is the routine test. So type test, these type tests are performed to check whether the performance of the circuit breaker is as per design or not. For this, some circuit breakers are randomly selected and tests are performed on them and their performance is checked. What about the routine test is, after the type test, the design of the circuit breaker is confirmed. Then the prototype is developed and the manufacturing of the circuit breaker is done. Then the routine tests are performed on each circuit breaker. Routine tests are performed as per the international standards or as per the Indian standards. These tests are performed at the premises of the manufacturer. So this is the basic idea of the circuit breaker testing to verify its operation and its design constraint.
Which type tests are performed on circuit breaker? If this question asked in the examination, you have to answer like this. First is mechanical test conducted on the circuit breaker. These are type tests. Thermal test, dielectric test, short circuit test, and in case of short circuit test there are certain tests like making capacity test, breaking capacity test, duty cycle test, and short time current rating test.
Explain mechanical test or mechanical endurance tests performed on circuit breaker. So actually this test can be asked like mechanical test or mechanical endurance test. Both are one and same. So the mechanical endurance test is a type test performed on circuit breakers to verify their mechanical reliability, durability, and long-term operating performance without electrical load. It is to be carried out to check the strength and wear resistance of the moving parts to ensure the reliability of the operating mechanism during repeated operations, to confirm that the breaker can perform the required number of opening and closing operations without mechanical failure, and to verify smooth and correct motion of the contacts, linkages, and tripping or closing mechanisms. In this type of test, breaker is operated repeatedly, that is opening and closing like this, making and breaking of the contact without current. This is called no load operation. The total number of operations depends on the mechanical class of the breakers, like for class M1 total 2000 operations are performed, and for class M2 total 10,000 operations are performed. The operating mechanism is cycled using manual operation, motor or spring charged mechanism. During the test, following are monitored like speed of the opening and closing, correct sequence of latching, smooth movement of contacts, no abnormal noise or jerks, no wear, breakage or deformation. After completing all operations, breaker is inspected for mechanical wear, cracks, loose parts, lubrication condition, contact alignment, etc. Breaker must still operate normally and meet all the design parameters. In some cases, about 500 times without passing the current through the contacts operation is done. Out of this, about 50 operations are done by energizing the relaying coil while the remaining operations are done by the energizing the trip coil through some other means. No adjustment are permitted during this test. No distortion or wear should be occur in the moving part or the contact parts. A circuit breaker passes the mechanical endurance test if it completes all required operations without any failure. There is no excessive wear, deformation or damage. Opening and closing times stay within the permissible limit or tolerance limit. Contact movement and alignment remain within the tolerance, and operating mechanism functions smoothly even after thousands of the operations. So these are some cross checks of the design of the circuit breaker. So mechanical endurance test, that is the basic type test, is very important for the circuit breaker design reliability check, and also check its wear and tear and its smooth operation in all the conditions. Explain thermal or temperature rise test performed on a circuit breaker. So the temperature rise test is a type test carried out on circuit breakers to verify that all the current carrying parts, that is contacts, can safely carry the rated continuous current without overheating. The purpose is to ensure that the breaker can carry rated current continuously. To check that the temperature rise of live parts, terminals, contacts and insulating materials remains within the permissible limits, and to confirm that there is no excessive overheating which could cause insulation failure, contact deterioration or mechanical deformation. The circuit breaker is connected in a test circuit and loaded with its rated current, that is IR, that is rated current mentioned on the nameplate of the circuit breaker. Current is maintained continuously until a steady state temperature is reached, that is usually for 2 to 3 hours. Now temperature is measured at main contacts, terminal, current carrying conductors and mechanical parts that heat up. The measurement methods include thermocouples, infrared sensors and temperature indicators. The temperature rise should not be more than 40 degrees Celsius for the rated current less than 800 ampere, and it should not be more than 50 degrees Celsius for the rated current of more than 800 amperes. As per IEC, that is Electro Technical Commission Standards, or Indian Standard IS, permissible temperature rise for copper contacts is from 65 to 75 degrees Celsius rise, for aluminum parts 55 to 65 degrees Celsius, and for insulating material within the specified thermal class, that is class Y, A, E, B, F, H, C like, and for external metallic parts that are touchable should not be greater than 30 to 40 degrees Celsius rise. The circuit breaker passes the test if the temperature rise of all the parts is within the standard limits. No discoloration, that is the change of the color of the contacts, deformation or damage occurs, or contact resistance remains low and stable and no insulation deterioration is observed. So these are several informative details of temperature rise test or thermal test that is carried out on the circuit breaker. Define and classify dielectric tests performed on circuit breaker. So dielectric tests are the high voltage tests performed on a circuit breaker to verify the insulation strength of its internal and external insulating parts. These tests ensure that the breaker can safely withstand over voltages, switching surges and normal operating voltages without insulation breakdown or flashover. Dielectric tests prove the electrical integrity of insulation under different voltage stresses. There are two types of dielectric tests performed on circuit breaker. First is power frequency test or power frequency withstand voltage test. Second is the impulse test or say lightning or switching surges test. So these are two dielectric tests performed on circuit breaker to verify its insulation strength. Explain power frequency withstand test performed on circuit breaker. So the power frequency withstand test is a dielectric type test performed on circuit breakers to verify the insulation strength at normal system frequency. It ensures that the breaker can safely withstand 50 Hz or 60 Hz AC voltage depending upon the country for a specified time without flashover or insulation breakdown. The test is performed to check the insulation capability between each pole and ground, between poles and across the open context of the circuit breaker. Also, to confirm that the insulation can withstand temporary overvoltages that occur during normal operation and to detect weakness such as moisture, cracks or degradation in insulation material. In this, the breaker is placed in its open position and sinusoidal AC voltage at power frequency, that is either at 50 Hz or 60 Hz, is applied using a high voltage test set. The test voltage is gradually increased to the specified value and maintained for continuously 1 minute or say 60 seconds. Measurements and observations are taken for flashover, breakdown and abnormal noise or corona. The test is repeated for phase to earth, phase to phase and across the open context of the circuit breaker. Test values depend on rated voltage of the breaker as per IEC or IS standards. For 12 kV breaker, around 28 kV AC is applied for 1 minute and for 33 kV breaker, around 70 kV AC is applied for 1 minute. The circuit breaker passes the test if no flashover occurs, no insulation breakdown happens and no abnormal discharge, partial discharge or tracking marks appear and dielectric strength remains stable throughout the test time. It forms a key part for the insulation coordination. So this is about the power frequency voltage withstand test performed on circuit breaker. Explain impulse test performed on circuit breaker. So the impulse test, also called as the lightning impulse withstand test, is a dielectric type test performed on circuit breakers to verify their ability to withstand high voltage lightning surges. The surges are very steep, short duration, over voltages that appear on the power systems due to lightning strokes or switching surges. The test ensures the insulation of the circuit breaker that can withstand transient over voltages without any flashover or insulation breakdown. The test is carried out to check the insulation strength of the breaker under lightning type surges, to evaluate the impulse withstand capability of the bushings, contacts, interrupters and external insulation. Also to ensure reliable performance against very fast rising voltage transients and to detect the weak spots or say the hot spots, air gaps, voids, that is the deformation points or defects in the insulation. In this, the breaker is kept in open position. The high voltage impulse generators, that is Marx generator, produces the 1.2/15 microseconds waveform, that is the standard impulse waveform is applied. The test is carried out or repeated for phase to earth, phase to phase and across the open context of the circuit breakers. A series of impulses like 3 positive polarity impulses and 3 negative polarity impulses are applied. Voltage is usually raised until the specified insulation withstand level, that is basic insulation level BIL, is reached. For 12 kilovolt breaker, around 75 kV peak applied. For 33 kV breaker, around 170 kilovolt peak is applied, and for 132 kV breakers, around 550 kilovolt peak voltage is applied. The circuit breaker passes the test if no flashover occurs, no internal breakdown noticed, no surface tracking or punctures, and insulation remains stable and free from partial discharge damages. If the flashover occurs externally, that is in the air, but not across the tested insulation, the test may be repeated again. It ensures the safe operation during lightning strikes. It provides the confidence in insulation coordination for the system, identifies the weakest or weak insulation points early in the manufacturing stage, and ensures the long-term dielectric reliability of the circuit breaker. So this is all about the impulse test performed on the circuit breaker.
Explain brief idea of short circuit test performed on circuit breaker. So such tests are performed in the short circuit station and the ratings of the circuit breaker are checked. Such testing stations are of two types: field type testing stations and laboratory type testing stations. Now in the field type testing station, the required power is taken from the power system. So the bulk power required for the testing is available readily from the grid. This method is economical, but it is not suitable for test and research work because frequent testing is not possible and it is difficult to control the transient recovery voltage, triple RV, etc. Now in the laboratory type testing stations, required power is obtained from the specially designed generator. Such generators are designed with less reactance, so the reactance is less so that they can supply large short circuit current. The following equipments are used in addition to the generators. These are short circuit transformer. It is used to get necessary test voltage. Master circuit breaker. So it is a backup type of circuit breaker if sometimes the circuit breaker under test does not trip during the operation. This backup circuit breaker trips and saves the apparatus. Making switch. It is used to supply short circuit current at the required time. The making switch is made on after the master circuit breaker and the circuit breaker under test are made on. Capacitor. It is used to control the rate of rise of restriking voltage, that is triple RV, and for synthetic testing. Resistors and reactor. These are used to limit the short circuit test current. So this is the basic brief idea of short circuit test performed on a circuit. Explain making capacity test performed on circuit breaker. So the making capacity test is a short circuit type test carried out on the circuit breakers to verify their ability to close onto a fault and carry the first peak of the short circuit current safely. When a breaker closes during a fault, the current rises rapidly to a very high asymmetrical peak value due to DC offset. This peak current is much higher than the rated symmetrical short circuit current. The making capacity test ensures that the breaker can withstand this electrodynamic stress without any damage. The test is carried out to verify that the breaker can close onto a short circuit, to check its ability to withstand the first major asymmetrical current peak, contacts, mechanism
An interrupter can tolerate the electrodynamic forces caused by the peak short circuit current, and to prove the breaker's closing mechanism is strong enough under the fault conditions. In this, the breaker is connected in a high current test circuit. A three-phase short circuit is created at the breaker terminals. The breaker is commanded to close onto this fault. The resulting first major peak current is recorded. This test is repeated for making from open position and making during the operating duty cycle, that is open, time delayed, closing operation followed by the opening, again time delayed of 3 minutes and closing followed by the opening operation. The observations are made from contact bounce, welding or deformation, excessive mechanical stress and heating or damage. The breaker passes the making capacity test if it successfully closes onto the short circuit. The breaker can continue the remaining part of the opening duty cycle, and it carries the rated making current without instability. So it ensures the reliability during the real network faults. It confirms that the breaker can withstand the highest mechanical forces seen in the lifetime, and proves that the breaker can safely make and carry short circuit currents until the breaking operation occurs. So this is how the making capacity test performed on a circuit breaker.